Good evening, everyone. How are you? You might be wondering why I'm starting out with a knife. Not the typical introduction for a chemistry video, but I'm going to do something with this, and also this is a very special knife. This is a knife that my grandfather gave me that was his, and it looks really cool. So let me show it to you. I also like how it has this casing with it. This leather casing. And beautiful stainless steel. On this side, look, I love this. It's got an engraving that is in Finnish, I believe, and because that's where this was made. I can't pronounce it, so if you are Finnish and you can tell us where this is, but thinking that's the city, and there's it says Finland. So anyway, I love this knife. It's quite exquisite, and such a nice handle. Look at that, a nice grip on it. So I thought I've made a couple gym chalk videos, and I thought I would do a little bit of slicing with this knife. This gym chalk is from a previous video, but I just wanted to get the sounds of this slicing. So I'm going to get the mic maybe a little bit closer. I want to move it down a little bit. And just see if we can pick up some of this slicing, the sound of slicing. Almost like a carving. You can get it from the side. Try to slice it this way. I really like this. How smooth it is. And I know that crumbling the chalk is a big thing, or has been, or was. Things come and go so quickly, right? But I really like this smoothness of this slice. Oh, what's that? This gym chalk is calcium carbonate. It's very, very not dense. It's funny because I'm not sure what the word is for that. If something is dense, we know what to say. It's dense, but if it's not dense, what do you say? Very satisfying. Oh, look how smooth that is. I love that. Alright. Well, thank you for appeasing me. Hanging out with the chalk slicing activity. Okay, well, let's get to the main topic of today's video. So, it snapped. I get lots of requests for various topics. And my intention is to always get to all the topics eventually. But the problem is I get lots of requests and it's hard to keep up with them, with the number of videos. So there's a couple ways you can get your request bumped to the top. And one of them is if you join the channel. And joining at the lowest tier is actually super affordable. It's less than a fancy cup of coffee per month, and it helps me a lot just buying stuff and getting more different resources, like my calligraphy stuff and my audio stuff and everything. So that's cool. And also, I would just love to continue to build up the community that we have here, because our community is amazing. All of you are so awesome and just really kind and appreciative, and I just really so much appreciate it. And I hope you can tell that I love making these videos. I've been doing this at the time of making this video. You might be watching it later, but right now it's 2022 and I've been doing this channel for 2 years, and it really brings me so much joy. It's just in 2 years I have made $103 off of this channel. So I'm definitely not doing it for the money. I am doing it just because I love it so much. And I have to say, part of why I love it so much is the amazing people, you, and the really awesome comments that you post. Be careful not to cut myself. Okay. So I wanted to thank you and then just also tell you about the ways that you can join the channel and get more stuff from me. I have 3 tiers, and one of them is actually you would get me making you a video just for you to answer your questions. And that one does cost a lot more just because it would take me a lot of time to do it. But I definitely do not expect many of you to do that, for sure. But if you did want one, that is available. Okay. I think I could just do this all night. This is so much fun. Okay, but let's do some chemistry. I've actually talked about the chemistry of calcium carbonate in my video that is more focused all on the gym chalk, and I do crumbling of gym chalk, and I talk all about the chemistry of it in a different video, so you can check that out. Look for that one. Okay, but this video, I'm gonna move my, sorry about that. Okay. I'm going to move my gym chalk out of the way, reassemble things here, move them around. Okay. And lo and behold, underneath this is paper for calligraphy. Okay, set this aside. Set that over there. Okay. Let's get this clean. All right. So, of course, I need my calligraphy pen. And I need some ink. So I use this brand of ink and type of ink, and I use black, although I do have red and I have gold as well. And in my About section on my page, if you are interested in trying out any of this ink or calligraphy pens that I like, I have the links to those. So you can get the exact same ones that I have if you would like. But I know some of you have zero interest in doing the calligraphy yourself, and you just like to watch and learn about chemistry. Okay. So it's funny because I don't know how, I have no idea how, I lost my ink holder, and so I'm using a different one, which is just a cap from a soda bottle. So look, I took a cap and I just filled it with the ink. Right, so reduce, reuse, recycle, right? Okay, that's what we're doing. So I feel like we're just now beginning. And thank you for being here. As I said, I love doing this. And let's get to the topic. So the topic, we're going to be talking about electronic transitions and the structure of the atom. And one of the reasons why I love this topic is that it also ties in history and the all-important structure of the atom that tells us where are those electrons. Because in chemistry, you know, it really all comes down to the electrons, the movement of electrons, whether electrons are shared, or if there's a mismatch of electrons with protons, which gives you an ion. All of those different aspects of where the electrons are is key to pretty much everything in chemistry. So there are a few different aspects of electronic transitions, and we are going to look at this first off based on the Bohr model. So the Bohr model is exactly that. It is a model. It is not depicting exactly what an atom looks like, but what it is modeling, which is essentially a simplification. But when we have models, they're used because they work. And they work for certain things that are important for us to understand. So some people say when they learned the Bohr model, they were then told, that they were lied to. and I get that, but I wouldn't look at it that way because it served a purpose. And the purpose of the Bohr model is to acknowledge some of the things that are true about the atom, such as the nucleus being in the center. That is something that still holds with all the studies that have been done. Another thing that holds is that for the hydrogen atom, the energy, I'm just drawing semicircles here, by the way. Okay, so these would presumably be energies that where the electrons can be all around the atom, but we're just focusing here. And if we were to call this energy level N, and if it's the lowest energy, we'll call it 1, and the second highest we'll call 2. And the distance, if an electron is here, the distance between the lowest energy level and the proton is going to be related to the energy of that electron as well. So we can call this, for the hydrogen atom, and maybe I'll write that up here. Let's remind ourselves of that, because hydrogen atom is the simplest, and some things work for a hydrogen atom that do not work for other atoms. The reason for that is it only has one electron. So if you have ions where there's also only one electron, many of these things work for that as well. Okay, so your electron here in the lowest energy level, and at this closest distance, this has the lowest energy. Also known as the ground state. All right. And this is also, as I said, it is the closest to the nucleus. Am I writing too small? Nucleus. Okay. So because this n equals 1 has the lowest energy, the electrons will tend to occupy n equals 1. However, if that electron were to absorb some kind of energy, some form of energy, that was exactly equal to the energy difference between n equals 1 and n equals 2, then it could gain that energy and be promoted up to n equals 2. But it is crucial. Oh, what is that noise? Oh my goodness. Oh, hang on a second. Wow. Thank you for your patience and understanding. Okay. So, here's that electron. And if that electron is to get excited up to n equals equals 2, the amount of energy that it would have to absorb must be equal to exactly that difference between 1 and 2. Okay, so the energy that it absorbs, it can come in various forms. One of those forms can be light. Okay, so let's imagine a photon of light comes in. And one way that's often used to show a photon is by writing h nu. And then with a wave and an arrow showing the direction. And the reason why this is a common symbol to show a photon is that h nu is referring to the energy of a photon with Planck's constant and the frequency of that photon. And that is giving a tip of the hat to the fact that light has particle-like nature, a photon. And then the wave here with the arrow, this is tipping a hat to the wave-like nature of light. So this is our wave-particle duality of light. Okay, so then if this photon of light hits that electron and has the correct energy, that electron can absorb that light. And it can get excited up. So let's draw what would happen in the next step, essentially. I'll try to draw the distances similar, as close as possible. Okay, there's our n equals 2. Our n equals 1. And here's now our excited electron. Okay. So let's think about this. The energy of the photon as I said, it had to be equal to the difference between n equals 2. Oops. Sorry, that's supposed to be a negative sign. Oh my goodness. How can I fix this? I could make it really thick. Let's do this. I'll make these thick too. Okay. It must be equal to the difference between n equals 2 and the energy. Can you hear? That's Neil. That's my pup, my little corgi. He decided to come in and join us. Neil. Neil. He was chewing on like a little piece of wood. I don't know where he got that. There's all sorts of shenanigans going on tonight. Oh, okay. Let me know if you think I should edit these things out, or if it's no big deal and I just keep them in. Yeah, let me know. Let me know if you care or not that there's just regular, everyday things going on in the house. Okay, so I'm going to keep up with the theme with a thick equal sign here. Okay, so the photon energy, the energy of this photon coming in, has to be equal to the difference between these two energies, this one and this one. And you can also just refer to that as delta. Okay, that's the difference between, and we could just abbreviate 2 minus 1 like that. Okay, so that would be the energy of just one photon. Now you could calculate what wavelength of light that would be, because, as I said earlier, if you know the frequency of the photon, and there's Planck's constant, then you can calculate what that energy is, and then you would know the difference in energy of those two. And if you prefer, you could calculate the wavelength. So there's Planck's constant, as well as the speed of light. And then that allows you to calculate, I just want to make that a little bit darker, what the wavelength of light is that way. Okay. So here we have absorption. Okay, that's what this is. So this, here, I'll put it, the header right here. This is absorption. And this is specifically absorption of light. So the electrons can absorb heat energy. They can also absorb kinetic energy. So there are other ways that this can happen. And I'm just using the example of if there is a photon. Okay. All right, so another kind of transition is essentially immediately what happens after an electron gets excited. And that is that spontaneously those electrons will fall back down to lower energy states. So generally speaking, something to keep in mind that when you have something in a higher energy state, its tendency will be to drop back down. And when that electron that's excited drops back down, it will then emit a photon. So once again, we can show that squiggly line, each new. All right, and this process from here is emission. And again, what I'm showing specifically here is emission of light. So again, you can have other types of emission. You can have non-radiative emission. And so again, that could be from collisions. If your hydrogen atom gets hit by another hydrogen atom, then that energy, this could drop back down, but the energy could be transferred to the other particle. So it doesn't always have to be a photon, but there does need to be the absorption of some kind of energy to get it to go up, and then the emission of some kind of energy for the electron to go down. And believe me, that electron will go down. There needs to be something to keep it up there if it stays up there. So some excited states are somewhat stable. We call those metastable. And then they can stay up there a little bit longer. The electron will eventually transition back down, but it can stay up a little longer. And one example of that is phosphorescence. So, for example, it's actually really funny. I happen to have these glow sticks with me right now. They're sitting right here. I was not expecting, oh my gosh, that I would get these out, but hey, here we are. So I may as well. Okay. So these are actually a great example. In fact, I wonder if I turn off this light, it might look better. So, here's the stick. And we crack it, right? And you can begin to see that fluorescence happening. And it's spreading. Oh, that's pretty cool. You can see that here. I'll cover up the light a little bit more from this side. You can see that. Okay. So, and then, you know, I don't know if you've been told to shake it, but shaking it allows it to mix even more. Okay, I'll get this over here. Shake it a little bit. Okay. Isn't that cool? Okay. So, what's happening here with these glow sticks is that we are getting this emission of light that we just talked about, but that there is a metastable state. And so these electrons that are excited, I was talking about here, they're actually hanging out there for a little bit longer up in that excited state. And so slowly, ever so slowly, they drop down, they drop down, drop down. But some of them stay excited, a few more drop down, and this happens on a relatively long scale, over a few minutes, over, let's see if this says how long these last, but how long do glow sticks last? Seems like they usually last 20 minutes, half an hour, sometimes a little bit longer. You can still see a little bit of light coming out, and that's because of that metastable state and that the electrons are slowly dropping. And so over the course of time, we are slowly seeing photons of a certain wavelength of light. All right? It's the same idea. I'm going to turn this light back on. Same idea with those. Look at this. So you can't even tell it glows when you turn the light back on. That's cool. It's the same idea when you have those stars that you put on your ceiling, and then you charge them up by shining light on them. And that's what you're doing, is when you shine your room lights on them. This is also true for any like glow-in-the-dark t-shirt you have or anything else. You shine regular light on them, and it absorbs electrons, and then they get up in a metastable state, and then you turn off the lights, and then slowly, slowly, the electrons drop back down over the course of a few minutes, and light is coming out in that process. So that is the story behind glow sticks. All right. Wow. So we got in a little gym chalk slicing. We got in a little glow stick action. I really like doing small demonstrations, and I hope you enjoyed it too. So don't forget you can, have the option to join my channel. Don't worry if you do not. Everything's going to stay the same. I'm going to make videos for everyone that are free, as always, as always. I love doing this, so don't worry about that. So it's only if you just want a little bit extra stuff that you can join the channel. Be part of that community too. Alright, one last thing I want to mention, and that is I am now live streaming on Twitch. So if you happen to be on Twitch, you can check that out. The style is different from what I do here, although sometimes I do ASMR. But most of the time I don't. But still, it's very solid chemistry instruction. So if that's what you're looking for, then you can look me up. And here is my handle. It is Chemistry Rockstar. Okay, so this is on twitch.tv. This is free also. So, just more chemistry resources if that's helpful for you. It's called Chemistry Rockstar because I also play in rock bands. I play guitar. So a lot of people just kind of called me that. So I decided to pick that name for my Twitch handle. Alright. Well, thank you. Thank you, as always, for being here with me, for hanging out. And as always, let me know your requests. I love getting them. And I am way behind on my list of requests, but I swear I'm chugging through them. And I will try to do as many as I can. And maybe I'll get caught up someday. That would be awesome. Alright. Have a wonderful evening, and I will see you again next time.